Good morning, everyone. Now, Mr. McKeever, we have Dr. Walker today.
We do.
Good morning, Dr. Walker. As you appreciate, you're about to be asked questions by Mr. McKeever, who's sitting opposite you. But first, I understand you're prepared to affirm.
Yes.
Sitting where you are, would you repeat these words after me? I solemnly, sincerely, and truly
I solemnly, sincerely, and truly
declare and affirm
declare and affirm
that I will tell the truth,
that I will tell the truth,
the whole truth,
the whole truth,
and nothing but the truth.
and nothing but the truth.
Thank you very much, Dr. Walker. Can I encourage you, when answering questions from Mr. McKeever, to perhaps keep your voice up a little bit above the level that you would use in normal conversation?
Okay.
You've got the microphones there, but there's quite a large space to fill, and it's important that I hear what you have to say. I think your evidence will take most of today. We've certainly scheduled it for today. We'll take a coffee break at about 11:30. But if at any stage you want to take a break for whatever reason, just give me an indication and we can always take a break. Now, Mr. McKeever.
Obliged, Lord. Good morning.
Good morning. Could you tell the inquiry your full name, please?
My name is James Target Walker,
And what's your occupation?
public health microbiologist.
For what organisation do you work?
I work for Walker on Water.
And am I right in understanding that that's your own company, your own consultancy company?
That's correct.
Now, you're aware that today we're interested in various matters to do with the Queen Elizabeth University Hospital in Glasgow, is that right?
Yes.
And I understand you were involved in some work at that hospital in two capacities, would that be correct?
Yes.
Now, the principal one that I'm concerned with is in your role as the author of an expert report that you've put to this inquiry. You recall that?
Yes, I do.
And I wonder if we could bring that up on screen, please. It's in the expert report bundle 21, volume 1, at page 180. So when I refer to a document, it will come up on the screen in front of you and we'll be able to read together what it says. So this is the title page from your report, is that right? You recognise that? And it's dated 21st of January 2024. Do you adopt that report as your evidence for the inquiry today? My questions to you will principally be about this report and about matters relating to that report as they might have arisen in evidence hitherto before the inquiry. But I mentioned that you'd been involved in two capacities, and as I understand it, your other involvement with the hospital occurred earlier, and you've alluded to that at section 10 of the report. If we go to page 340 of the bundle, section 10 will be there. And do we see at 10.4 onwards, halfway down the page, you make reference to having been invited as a representative, a PHE representative, to the hospital on the 5th of June 2014.
That's correct. PHE being Public Health England.
Was what I was going to ask. What is Public Health England?
Public Health England is a large, very large organisation within England which deals with, simply enough, the public health. And from my perspective, I was a research microbiologist within public health.
Okay, thank you. Could I ask you perhaps, I'm also having trouble picking up the top end of what you're saying. While I've been involved in this inquiry, I've managed to have a shell of microphones built up around me, and it helps me if I lean forward slightly.
Okay, I will.
It may, the same may help you.
Thank you.
So, sorry, you mentioned what Public Health England was. What was your role with it?
So my role within Public Health England varied over a number of years, but to the latter part of my career, I was a senior water expert within Public Health England, dealing with basically problem shooting and research programs related to water microbiology and the hazards and risks related to water within buildings.
I understand that around 2012, there was an incident in Northern Ireland relating to pathogen Pseudomonas that occurred in taps and water systems there. You had involvement with that, or as a result of that, during your time at Public Health England, is that correct?
Yes, I did. Public Health England were approached by colleagues in Northern Ireland to provide assistance in a number of ways. There was that expert advice over telecoms and meetings, but also providing research by the investigation of the tap components. And when I mean tap, I mean plumbing components that were associated in the neonatal ward where the outbreaks had occurred and the babies had become infected.
Now, on the page that's in front of you, do we see at 10.2, you have recorded certain concerns about that tap design?
Yes.
And perhaps I'll read out here what's said in the guidance. Owing to the high surface area to volume ratio and location at the tap outlet, certain designs of flow straightener may present a greater surface area for colonisation and support the growth of organisms. Therefore, when selecting new taps, where possible, flow straighteners should be avoided, not included. And there was advice against using aerators in outlets. For the benefit to, or in layman's terms, could you describe what that issue is?
So, end of tap generally have a mechanism within them to control the flow of the water as it leaves the tap to prevent splashing and possibly even slow down the flow. And those components generally within a tap are plastic components of a very high surface area, extremely complex units, highly engineered, that provide what's known as a high surface area for the growth of microorganisms, but they also retain debris and any silt within or sediment within the water will be basically encaptured within that framework of the flow straightener, and within that you will get what's called biofilm growth that is then dispersed as the tap is switched on, and that's dispersed into the basin and splashes out into the environment.
Okay, thank you. As a matter I'm going to come back to later in my questions, but that is what led up to you having been involved in this other capacity with Queen Elizabeth in 2014. At 10.4, midway down the page, you record, we've half read this already, but having been invited as a PhD representative and water microbiology expert to a meeting in the labs block at South Glasgow Hospital on the 5th of June 2014 to discuss the findings from the Northern Ireland outbreak, to explain the issues and problems associated with microbial, biofilm and waterborne pathogen colonisation of tap components. That's essentially what you've just told us a moment ago.
Yes.
And at 10.5, you record a summary of what happened at the meeting, and I'll come back to that in more detail later. And moving on from that, you then go on to record some other work that you carried out with PHE. 10.6 at the bottom records publishing and writing.
Yes.
Right? And then over the page, 10.7, you speak about co-authorising reviews. And 10.8, co-authoring a book on safe water.
Yes.
And at 10.9, there's academic type work, conferences and so on.
Yes. So they're basically to explain that I publish widely and regularly within the expert area in which I work.
So that's a source of your expertise.
Yes.
And it reflects your expertise in water microbiology.
Yes, and it's about sharing that experience with the wider domain, the wider scientific community.
And just to be clear, it's that expertise that led to your involvement with Public Health England and to your involvement in the meeting in June 2014.
Yes, very much so, yes.
Just before I step away from that, when you were at that meeting, were you working for Queen Elizabeth in any capacity?
My attendance at the meeting was as a Public Health England water microbiology research expert who'd been involved in a major outbreak of Pseudomonas aeruginosa within neonates and the deaths of babies and the consequent investigations which occurred.
Again, Dr. Walker, try not to let your voice drop.
Okay, my apologies.
I'm hard of hearing and I'm very conscious of that. But I think leaning forward into the microphones, I think, does help. But also maybe be conscious that it's not just conversation, it's production.
Thank you. Yeah, so very much I was there as an expert.
Did you have any executive role?
My role was to represent the work we carried out at Public Health England.
So stepping away from that particular involvement, I'd like to ask you just a few questions about your career, your expertise, and about limits to your expertise. Turning back to page 187. There's your introductory section. You begin introducing yourself there. You start at 1.1.1, obviously, with your studies, microbiology degree at Aberdeen.
Yes.
And then over a number of paragraphs following that, you speak about 30 years at the Portondown Centre of Applied Microbiology. Could you tell us a little bit about your career there?
Interestingly, from my degree in Aberdeen, where I set up laboratory models looking at the growth of what's called sulfate-reducing bacteria on surfaces, which was my first investigation in biofilms, I then was able to apply for a job at Portondown Sorb as a junior microbiologist, looking at the growth of bacteria on what was going to be copper surfaces related to a problem that actually had occurred in Scotland hospitals in the 1980s. And from there, I spent many years working as a research microbiologist, and then through a series of advancements in my career and working on a different range of microorganisms, became an expert through time and gained my PhD through my work. And that led to further management roles, and then the final expert role in water microbiology as a PHE expert.
And indeed, on this page and the next page, going down to around section 1.1.10, you've given details of a number of projects you were involved in, and I don't need to go to those individually. Over the page, again, at 1.111 to 14, you mention professional groups, professional bodies that you were part of.
Yes. And many of those groups led to writing of government guidance, at the time were being Department of Health for England, but also British standards and European guidance related to waterborne microorganisms and outbreaks and prevention of those outbreaks within buildings.
Okay, and I don't think I asked you specific with the question earlier on, but when you mentioned having written guidance, among that guidance was, am I correct in understanding that that included guidance relating to the Northern Ireland outbreak?
It did, yes. Which was specifically for Department of Health England.
Thank you. Just to complete that page, 15 and 16, you're mentioning some teaching roles again, and again, in the two paragraphs at the bottom, more authorship.
Yes.
Before, over the page at 1.1.19, you describe the having formed your consultancy, or having taken a career break and having formed your consultancy, Walker on Water. And
yes.
Effectively, does that take us up to now?
It does, yes.
Yeah, that's the role you're in now. Paragraphs 20 and 21 there are mentioning your involvement with the inquiry, and if I may just read 1.1.21 to you, you say, as a water microbiologist, I've used my expertise and experience to assist the inquiry by assessing the microbiological status of the water and wastewater system in QH and RHC from the point at which the patient's occupation took place. This included assessing and understanding transmission routes through which the patients were exposed from the water and wastewater systems. I understand my duty to be impartial in presenting and assessing that evidence, and that my expert opinion would help the court, inverted commas, court, with its task. Can you confirm that that remains, that continues to be your position today?
That does continue to be my position, thank you.
Paragraph below, that's the key questions that you were asked to assist the inquiry on. first of those was from the point at which there were patients in the hospital. Was the water system in an unsafe condition in the sense that it presented an additional risk of avoidable infection to patients?
Yes.
And 2 was similar question, but relating to the present. Is the water distribution system no longer in an unsafe condition in the sense that it now presents no additional avoidable risk of infection?
That's correct. That is the questions which I set out to answer.
So broadly speaking, that's 2 questions. One is past looking and one is present looking.
Correct.
And does that determine, in broad terms, the structure of the later part of your report? At section 6, you're looking at how the system was. At section 7, you're considering how it is now.
It does, yes.
And there are some ancillary questions mentioned below, and then over the page again, it's paragraph 24 onwards, you set out your other duties of the expert as regards impartiality, candour, not exceeding your expertise, and so on. That, again, does that remain your position today?
It does, yes, thank you.
Now, before I conclude on this part of the report, it's important to be clear about your expertise, where it begins and where it ends. So your expertise, as you've told us, is a water microbiologist, is that correct?
That's correct, yes.
But there are some other areas that the report may or may not touch upon, and where I would have to ask you as to your view as to whether you have expertise in these areas. So I would put these to you and you can tell me if you agree or disagree with the suggestion. The first would be in relation to molecular strain typing. Is that a matter in which you have expertise?
It's an area in which I've been involved in a number of outbreaks where other experts have undertaken the speciality involved in the typing of strains from the environment and from the patient, and using their own expertise, they have judged that it's similar or not. So it's out with my own expertise.
Sorry, that was, I didn't quite catch the last bit.
Out with my expertise.
That's out with your expertise, thank you. The second area would be the application of whole genome sequencing. Is that a matter that's inside or outside your expertise?
That's outside my expertise in terms of the detail of how it's done.
The third is the identification of genetic linking of organisms.
Again, that's similar to the whole genome sequencing question. It's out with the expertise which I have in terms of the detail of the mechanisms and technologies used to achieve those outcomes.
And the fourth is the assessment of clinical risk.
I would leave that to the clinical teams involved to determine that for the safety of the patients who they are looking after. But very much aware from my own expertise in terms of water, how the risk happens from the water system.
Okay, thank you. So to summarise that, they're matters you have some familiarity with, but you wouldn't go so far as to claim expertise in those 4 matters.
Correct.
Right. Thank you. As I mentioned, I'm going to principally refer you to this expert report. Where there's another document I'd like you to have a look at that will come up on the screen in front of you. The report is fairly lengthy, as you're no doubt well aware. We're at nearly 200 pages. For reasons of time alone, it's not my intention to attempt to take you to all of it. Simply be impossible to do so. Instead, I'm principally interested in the 2 sections that I mentioned, 6 and 7, which were the past and present assessments. To some extent, I'll ask you questions also about section 4, which will be the description of the system as installed, and section 5, which I understand to be your description of what might be described as hypothetical water systems or unsafe features that one might see in a water system generally. Have I got that right?
Yeah, we can discuss that when we get to those points.
So again, I'll
just the word hypothetical, that section's based on experience over very, very many years for myself and with colleagues, and understanding the implications where systems are either not managed or become a risk to patients.
Okay, thank you. Well, that's an important point where you have the expertise, I don't, where I may slip in terms of words choice or so, and I'm grateful to you for picking up on those.
Fine.
So I'll try to be quite focused on my questions and grateful if you could do the same with the answers.
Thank you.
So section 4 was the earliest of those that I mentioned, and it begins at page 208. And there you're setting out an introduction and applicable standards used in the system. First reference I'd like to take you to is page 211 and section 4.3, which is the supply of wholesome water. Do you see that?
Yes, I do.
And you've started out there by giving us a description of wholesome water. Water delivered in Scotland, at paragraph 4.3.1. Water delivered in Scotland by the water supplier is considered as, quotes, wholesome water, which is fit to use for drinking, cooking, food preparation or washing without any potential danger to human health.
Yes.
Now, am I correct in thinking that that is your paraphrasing of a statutory definition?
That is correct.
And you've given a at footnote 80 there at the bottom, we can see it's the 2001 regulations.
Yes.
Now, one point worth taking from that is that the regulations, as I read it, aren't presupposing that the water needs to be sterile in order to be wholesome. Would that be correct?
Wholesome and sterile are very, very different terms in terms of the outcome of the water. Sterile would be where there's no bacteria in the water. Wholesome is where it applies to the definition that's there in front of you, 4.3.1, applies to the water. It will have bacteria within it, but it must meet certain definitions once it enters the building and once it exits the tap where the patients are going to be. But we have to consider that that water may not be appropriate for all the patients within the hospital, maybe patients who are at high risk. And if you have a clinical decision, that water may have to be of a higher standard for those patients.
Okay. So the key test would be the potential danger to human health.
Yes.
And that's completely different from thinking in terms of sterility, which is about the actual content, an absolute test in terms of the content.
Very absolute, yes.
So in fact, the presence of microorganisms in the water is not incompatible with wholesomeness.
No, it's not.
And indeed, if we look at the bottom of the page of 4.3.4, you're perhaps setting that out in better terms than I asked you there, where you're saying that wholesome water is not sterile and will contain microorganisms. And then whilst wholesome water may be safe for most patients, the provision of the supply of this water in areas where vulnerable patients are present should be risk assessed to prevent infection in susceptible patient groups. And that, I think, is what you were describing to me a moment ago.
Yes.
Does it follow from that that water that's found in a hospital will inevitably have microorganisms within it?
Yes, because the water only needs to be wholesome. But where a clinical decision is made that the water needs to be sterile for certain patient groups, then that water will be sterile.
Dr. Walker, I'm continuing to find difficulty in hearing what you're saying. I don't know if our technical people can,
or can you,
as it were, ramp up a system.
I think they're on as high as they can.
Yeah, okay.
Right.
I will try and project more.
Yeah, I mean, it's not straightforward. We don't often find ourselves giving evidence, but I'm just not hearing enough.
Apologies, my lord. The best I could do, I'm afraid, is the leaning forward trick.
Yes,
It's not great for the back, but it is an encouragement to speak fast.
I'll cope.
So if it follows that water in the system will inevitably have microorganisms within it, then does it follow that for water safety, it's not so much a question of keeping microorganisms out of the system? Is that right?
You do not have to keep them out of the system for the majority of the patient groups within the hospital.
What, therefore, are the important things to have regards to when running a water system?
As the water delivered to the hospital is wholesome, then the water leaving the taps should be wholesome. And therefore that water has to be managed from the point at which it enters the building, passes through all the various water equipment and components, and is then delivered to the outlets where the patients would be. And the importance in general terms from a microbiological perspective are keep the hot water hot, the cold water cold, and keep the water moving. Now, they're very simple layman's terms, but they fulfill basic requirements in order to prevent opportunities for microbial growth within the water system.
Okay, thank you. And I'll come on, I think, to each of those in turn. But that's a very pithy description, and I'll just ask you about the importance of those three elements. Why is keeping hot water hot important?
So in terms of the hot water, the regulations for healthcare are that the water in the chlorifier, the hot water cylinder that provides the hot water for all of the hospital, the water should be heated to 60 degrees centigrade. That hot water is then flowed round the hospital, and it should return at 55. And that will reduce and control, to the best of its ability, the microorganisms within the hot water system. And in terms of the cold,
how does, sorry, just in one sentence if you can, how does keeping hot water hot reduce the amount of...
It prevents the microorganisms from multiplying.
Thank you. So that was the first, keeping hot water hot. Second was keep cold water cold. How does that work?
So again, that's keeping the temperature below 20 degrees or lower, and reducing the opportunities for microbial growth to multiply.
So again, that's about proliferation.
Yeah.
Is that right? And the third element was keep it moving. How does that work?
So keeping it moving means you're flushing the microorganisms that are in the water through the water system and out of the taps. So you're removing the microorganisms from the water system by keeping the water moving.
Thank you. The next section I'd like to look at is a few pages further on, 224. And I should say that this, I'm moving at speed through this part of the report, but in this part of the report, you are, in summary, you're looking element by element at the water system. And I'm afraid for reasons of time, I'm picking out parts that seem to me to be interesting or important. The first of those is at the foot of the page, 4.15 on pipework. Now, the first thing you do there is refer to the employer's requirements governing the build, where it's stated that in respect of water systems and filtration, pipework shall be stainless steel with compatible accessories. And then you note, however, the photographic evidence, and you give a reference to that, and I'll go to that in a moment, only indicates the presence of copper for the main domestic hot and cold water system. So you're putting your finger on an incompatibility here between the requirements for the general pipework in stainless steel and what you've seen in terms of a copper fitting. Is that correct?
Correct.
Now, I will take you to a photograph or two. First one is within the same report at page 390. It's not at page 390. Sorry, give me a moment. I'll see if I can identify what I should have referred to. We may have to do without the picture. I'm afraid that's my mistake. Apologise. The picture that I'd intended to take you to, I think you'll be familiar with it. It was a picture of a copper tail. Was that correct?
Correct.
You recall what I'm talking about here?
Yes, a hard fixed copper tail.
Could you tell me what a tail is, please?
So, for example, you have your hot water system which has a flow and a return, and we know that those ran in the sealing voids. And from the flow and return, you'll have a spur going down to an outlet, such as a hand wash basin. And it looks like those spurs or tails ended up in copper, whereas the system specification was for stainless steel.
Okay, thank you. So you're drawing a distinction between the main pipework in the hospital and I think what you described as a spur
Yes.
which was a length taking us from the main pipework to the fitting, in this case, perhaps a tap, perhaps a shower, something like that.
Correct.
And am I right in understanding that it was that spur that is what you refer to when you talk about a tail?
Yes.
And you identified the tail that you saw as having been made of copper.
Correct.
What's the problem with making a tail out of copper?
The problem in terms of the Scottish technical guidance relates back to problems in the 1980s where there was debris and sediment within the Scottish hospitals, which led to failure of the copper pipework. And this was an extensive, very expensive problem related to replacement of miles of copper pipe within the hospitals. And because of those problems, the Scottish guidance was rewritten to ensure that there was filtration to prevent debris and sediment entering the pipework, but also that the pipework should then be in stainless steel such that it has a longer life, because the sediment and debris reduced the lifespan of the copper pipework.
And am I correct in understanding that this was a problem specific to Scotland?
No, it was specific to areas in the world which had soft water, quite often with upland water, with a lot of humic and fulvic acids within it, which was a debris which flowed through into the water systems and sedimented onto the pipes.
A combination of soft water plus debris plus copper
Plus bacteria.
Equals
What we referred to as pepper pot pitting and failure of vast quantities of the copper pipework within the hospitals.
the pipes started to disintegrate. Is that too
Yes.
strong a word?
Basically, they started to leak and fail and had to be replaced.
Okay, thank you. I think I've identified where I went wrong with the photo reference a moment ago. The copper tail that you were picking up, I think, was from a reference from a report by DMA Canyon in 2015. Do you recall that?
Yes.
That DMA report is at bundle 6, page 122. Is that the report? You recall seeing this?
Yes.
And in general terms, that's a report into Legionella, but reporting on the state of the water system as it stood at April, May 2015. Is that correct?
Yes, it was a Legionella risk assessment of the entire water system.
If we move on to page 390 of this document, then with luck, there should be a photograph here. If we see...
Just before we do that, Dr. Walker, you referred to Scottish guidance. I'm assuming, unless you tell me differently, that that's SHTM 0401. Is that
Yes,
right?
correct.
Thank you.
So of these 6 photographs, the left-hand side, the middle photograph, it's marked small copper tails visible, and it refers to infrared taps and armatured shanks taps in endoscopy washroom. Is that the copper tail that, yeah, of
It's
the
one
type
of them,
that-
yes.
Did you see many of this sort of thing when you visited the hospital?
When I visited, the majority of the units which I looked at were actually behind the wall panels. So you have very little visibility of the pipework.
Okay. We have this photograph because here's a bit of the pipe poking out of the wall.
Yes.
And you can see here, because it's the brown line in the middle of the photograph, is that the copper tail?
And the one in the middle on the left-hand side, yes.
Thank you.
So we know there was copper within the system.
Thank you. And this particular copper tail is not very large, is that correct?
That one looks relatively short, yes.
I think in fairness, you don't know, or other copper tails.
We don't, correct.
Thank you. The next section I'm interested in, this is going back to your report, would be at paragraph 4.1.6, which ought to be in page 225. And here at 4.16, you're discussing supply of filtered cold water to different departments. Now, why I'm interested in this is here you are talking about, you're defining cold water by reference to temperature parameters.
Okay.
And I'll perhaps just read the first paragraph. Cold water is supplied to various departments and wards for use at the point of use. And you give some examples of that. You talk about end-of-line dump valves to discharge the water into the drain when the water temperature increases above 23 degrees, as there's reasonably foreseeable Legionella risk in water systems if the water temperature in all or some part of the system is greater than 20 degrees centigrade. And then again, in the paragraph under, at 416.2, you talk about the warmer the cold water, then the greater likelihood of microbial growth, which is what you told us earlier. Therefore, dumping cold water when the temperature reaches 23 degrees serves several purposes, and you list 3 of them: removal of microorganisms, reduction of water temperature, and replenishing any chemical disinfection. My question is that you mentioned 2 different temperatures here, 23 degrees for the dump valves, but 20 degrees for the Legionella risk. If we skip forward 40 pages to 265, at 512.3, you're discussing what you'll probably tell us about in a moment, about waterborne pathogens growing in temperature range of 25 to 45 degrees.
Yes.
Hence, guidance encourages the following. First bullet, keep the cold water cold at or below 20 degrees, preventing heat gain. And then for hot water, 60 degrees, 55 degrees, as you told us earlier. And you mention again the growth range 25 to 45.
Yes.
And then if we look over the page, there's a diagram of, with handy thermometer graphic, Legionella in a sort of vertical bell curve on the right-hand side with parameters 70 degrees, 60, 49, 25, and 0 degrees. Now, my question to you is really, can you help me by explaining those numbers? I'm particularly interested in the lower 20, 23, 25 boundary and why there isn't, or why you haven't used a single number for all 3.
Thank you. So in terms of the cold water, we know that the regulations try and keep below 20 degrees centigrade. And if the water starts to increase above 20 degrees, you will get more microbial growth. So the microbial growth may be in stasis below 20, but the more you go above 20 degrees centigrade, the more opportunity there will be for the potential growth of the microorganisms. And you have to have a cutoff somewhere in terms of, for example, you were just mentioning those dump valves. They could have chose 25, but you would have more growth. So it brought it down to 23. And it doesn't mean the bacteria are not growing at 23, but what you're doing when you operate a dump valve is you're moving that water at 23 and reducing the temperature back down. So you're reducing the opportunity for microbial growth as the cold water increases in temperature.
Okay, thank you. Number of questions I can think of as a result of that. And perhaps the first of them is answered by the bell curve graphic you've got in front of you. Can you describe how growth occurs, increases, and so on as the temperature rises above 20?
So microorganisms will grow better as the temperature increases. And as you get to 25, 30 degrees, you will get more bacteria growing more quickly. And as you increase above 30 to 37 to 40, you will hit the sweet spots that the bacteria will actually grow exponentially at. So by removing the temperature profiles from where you talked about that optimal growth range, where you have it lower, then you have reduced microbial growth. And if you keep it much higher, in the higher temperature range, 55 to 60, then you will reduce the potential for the bacteria to multiply within the water.
Okay, thank you. So am I correct in understanding then that there is a sweet spot or a peak, which is the thickest part of the bulge here, and that's
Yes.
between, I think you said, around 37 to 40 degrees.
Correct.
Is that right?
Yes.
But as we are moving towards that, am I correct in understanding you had stasis below 20 And then as you move above 20, you start to get some growth, but it doesn't become exponential until you get considerably above 20. Is that right?
Correct.
So does it follow from that then that when we're talking about 20 or 23 or 25, or the functions that I referred to you to a moment ago, that the choice of number there is essentially a pragmatic solution as to when is it best to have the, for example, dump valves come into operation?
It's about reducing the opportunity for microbial growth. It's about controlling that growth. And one of the methods of doing that, as we talked about, is temperature and keeping the water moving. And those dump valves basically satisfy both of those requirements by when you operate the dump valve, then you keep the water flowing, you remove any water with bacteria in it, but also you then replace it with water that is below 20 degrees centigrade.
In that case, then, is temperature and movement inherently linked?
They need to be linked. They need to be part of the control strategy for reducing the opportunities for microbial growth in the water system.
And keeping the water moving is part of keeping the temperature down or perhaps up at the other end of the room.
Correct.
And you've said the mechanisms by which this occurs is its replenishment with new colder water.
Correct.
And is there any other means by which movement assists in managing temperature?
So when the water is delivered to the hospital, it will have a residual chemical, chlorine within it. And as that water passes through the hospital, through the miles and miles of pipe, which each hospital has, that chlorine concentration will reduce. And therefore, when you have a dead-end pipe, for example, with those areas where you want to purge the water, then when you purge it, you remove the water, which may be at 23, which you're removing that potential for microbial growth. You're replacing it with water with a potentially higher chlorine concentration.
Okay, thank you. And is that because chlorine gets used up? Is that how it dissipates as it makes its way down the system?
That's any biocide which is entering a building will be challenged by the organic carbon within that building, organic carbon being debris, sediment, microorganisms. And as the water passes through the building, the more sediment, the more debris, the more microorganisms present, the more quenching and reduction of the biocide you will have as the water passes through the building.
So new water is helpful in summary in two ways. It provides fresh biocide and it also is colder, so it reduces the temperature. Thank you. Now, I took you quite far forward in the report there. Could we move back to page 231, please? And this is the soil, waste and drain system at the bottom of the page. If we go 2 pages further on to 233, there is a picture. Top picture is, in fact, I think it may be the same picture with the copper tail. In fact, now that I look at it, it's the left-hand side of this picture I'm interested in at this point. We have it marked trap below sink unit. You see that?
Yes, I do see it, yes.
Can you explain what that item is, please?
So basically that is a bottle trap that's attached to waste sinks, hand washing sinks or drains. And it's a bottle trap which basically contains the water, and the bottle trap contains the water to prevent foul odours coming back up the water system.
Does this fulfil a similar function to what a U-bend might in your house?
It does, yes, and bottle traps are used quite often where there is not the space or capacity for a U-bend.
Okay, one function that I have when I'm asking you questions is to gather together questions from other participants.
Okay.
And there are references in 1 or 2 places in the report to U-bends. And the suggestion I've had is that in actual fact there aren't U-bends present at the hospital and instead traps are universally used. Now, you've visited the hospital and you've viewed at least some of the apparatus. Does that tally with your recollection?
it does that there weren't U-bends, that there were bottle traps. And bottle traps, as we've just discussed, provide a similar control scenario to prevent odours coming back into the ward environment by having that bottle of water, hence a bottle trap, from the drains. And it also acts as a receptacle to collect any material that's poured down the basin or sink.
Okay, thank you.
Sorry, can I just make sure I understand the answer there? The proposition that was put to you, you've explained what a trap is under reference to the illustration.
Yes.
Now, the proposition that was put to you was that if you look at, if I understood it, if you look at the hospital overall, I think it was suggested by Mr. McIver, there are no U-bends. It's always traps that you find. Now, first of all, did I get the question right?
That's essentially it, my lord. The point was whether that conformed with Dr. Walker's.
So what's the answer to that?
Well, from what I observed and what I have in my photographs, there were only bottle traps. It doesn't, I can't categorically say there are no U-bends throughout
Right.
the hospital whatsoever. So
From your observation,
from my observation within the wards.
you agree with the
it was-
proposition?
Yes.
Right, thank you.
So there are, on occasion, references in the report to U-bends.
Yes.
And there's certainly one later on where you are talking about a kind of hypothetical or potential Section 5 features that one sees in water systems generally. There's a heading there that refers to U-bends. Where we come across that, we shouldn't understand that as being a specific reference to any U-bend that you'd seen at the Queen Elizabeth. Is that correct?
Correct, because the U-bend and the bottle trap perform the same function, and some hospitals will have U-bends and some will have bottle traps.
Thank you. Next passage I'm interested in is 3 pages further on at 236. Now, 4.26, flexible hoses and tails in the bottom part of that page. 426.1, you are making reference to an early document in the tender process, invitation to participate in competitive dialogue, which stated that, reading from it, stated that flexible hoses were prohibited in the build. However, these were found to have been fitted in the water system. At 426.2, you mention what they are for. Flexible hoses, also known as tails. Is that in distinction to, or is it just another type of the tails that we've already spoken about, copper tails?
So in real terms, flexible. These would be called flexible tails.
Do they fulfill the same function, essentially?
They do, yes, generally for connecting equipment to the hard copper or hard stainless steel, as maybe in some cases, water system.
So 2 points from this page. One, they were prohibited, but they've found to have been installed anyway. Is that correct?
Yes.
And 2, they essentially serve the function of taking water from the main pipework to the outlet.
An outlet being a piece of equipment or historically many flexible hoses, flexible tails were used to connect to sinks and basins.
Okay, so I don't know whether the word spur would be appropriate to refer
It
to.
would be, yes.
So spur, tail, these are examples of where
Yes.
one finds flexible hoses. Thank you.
Are you going to touch on at some point why they're prohibited?
Over the page,
Okay. Sorry.
at 426.3, you mention what they are typically made of. The outer casing of flexible hoses is typically braided steel or stainless steel with a synthetic rubber inner lining, such as EPDM. And you give the chemical name for that. This may be the question that you're looking for.
Okay,
What's the
thank you.
problem with that?
So the problem there is that, again, historically, microbiologists have demonstrated that this material, the EPDM, is a black rubberized carbon material, and it has various gaps and holes within it, allowing niche environments for the bacteria to grow on as a biofilm, but also that this rubberized material provides nutrients for the growth of bacteria. And these basically flexible tails, EPDM material, has been demonstrated to provide opportunities for microbial growth and resulted in a number of waterborne outbreaks.
So you're referring to 2 distinct problems with having an EPDM material in your flexible hose. Is that right?
Yes, that's correct.
Are they both serious problems?
They are issues which, when carrying out a risk assessment, that one needs to be aware that if they're present, you're increasing the risk and opportunities for microbial growth within the water system.
It may be worth dwelling upon them for a couple of minutes. The first thing that you mentioned, as I understood it, was the actual surface or constitution of the hose. You mentioned, I think, holes, perhaps cracking. Can you tell me about that constitution, please, and why that's a problem?
Basically, you'll have water supplied to a building, as we've discussed, has bacteria within it. Those bacteria will initially be in the water phase. However, over time, those bacteria will become attracted to surfaces where there may be sediment and debris, because they're going to use that sediment and debris as a nutrient source and then grow as a biofilm.
Why? Sorry.
And within the flexible hose, where you have a large surface area to volume ratio, because you have the inner lining of the flexible hose, but you also have niche holes within it into which the bacteria can enter and grow. And therefore, when you are using a biocide or increasing the flow rate to try and remove bacteria, you have a problem because you cannot access the holes in which the bacteria are actually growing as a biofilm. And the flexible hoses, because they're in nature, will enable the bacteria to grow at a greater rate and a greater density than a normal pipe within a water system.
Is that a function that's inherent to its flexibility?
That's a good question. No, because we have EPDM washers, which are also used within plumbing systems. And those washers will provide the same surface on which the bacteria to grow. But the flexible hoses need to be made of a flexible material because of the way they are used to connect one piece of equipment back to the plumbing system.
So is it too simple then for me to say that the stretchiness of the material is what causes these nooks and crannies, these holes, to open up?
That's an interesting question, but it's the surface material, regardless of whether it's stretchable or not, that provides a high surface area to volume ratio and provides the nutrients for the bacteria to grow, but it is designed to be compressible, if that's the word, or stretchable.
Okay, so in actual fact, do I follow correctly that even if they weren't bent, twisted, stretched, and so on, EPDM hoses would still present a risk because of what you've told us before? And that is essentially, the first part is from the surface area itself, which is rough, pitted, holes in it, and so on. Is that right?
Yes.
And then the second big issue that you mentioned was the material itself. And can you tell us about that? Why is that a problem?
The material itself is designed because it needs to be stretchable and flexible, and within it, it will have additives and hardeners, and those additives and hardeners within the rubber material provide nutrients for the growth of the microorganisms. So they're attracted to the surface, they'll grow on the surface as a biofilm, they'll produce a polysaccharide, and they'll take the nutrients from the surface of the rubber and grow. And it provides a greater opportunity for a greater density and more biofilm than, say, a hard steel or copper surface.
Okay, thank you. So to summarize that, then the double problem is that the material provides refuge where the organisms can get to and to harbour the organisms. And then the second problem is that that refuge itself is a food source.
Yes.
And that's why EPDM is a bad thing and is not to be used.
There's been many materials developed over many years, and it takes time for these materials to be recognised whether they provide opportunities for microbial growth or not. And that is one of the materials which has been demonstrated to be a risk for microbial growth.
Thank you. The final part that I want to look at, this section 4 of the report, is the section immediately below that, wash hand basin taps. Now over the page, at 427.2, you record that the specification called for pillar taps or armated shanks taps. Do you see that?
Yes, I do.
But 427.3, you record that in and around July 2012, contractor proposed the Horn Optitherm thermostatic bib tap instead, and that they were fitted. Is that right?
Correct.
And that if we move over the page one more again, we'll see two pictures of, is that the Horn Optitherm taps?
That is the horn tap, yes.
And these are the types of taps that prompted your meeting in 2014. Is that right?
Yes.
Now, I'll take that meeting at this point in the evidence. You've provided separately a witness statement as opposed to your expert witness report. And if we bring that up on screen, it's at bundle 11, page 161. We see here, this is your witness statement of Dr. James
Yes.
Walker. Are you content to adopt that statement as your evidence to the inquiry?
I am, yes. Yes.
Now, it's not my intention to take you through this witness statement just now because, and correct me if you have a different understanding from what I have, but my reading is that this witness statement is essentially setting out details around that meeting, what happened, how you came to be invited, and so on.
Yes.
But you've also made reference to that to that process in another document before the inquiry. If you recall, when you submitted your report, there was some follow-up Direction 5 questions put to you, and you submitted what might be termed a supplementary report.
Correct. Yeah.
And in part of that report, you recall that you also dealt with that meeting and with the horn taps.
I did, yes. There were questions related to that.
Right. For reasons of convenience, it seems to me easier if I take you through that meeting from the perspective of the Direction 5 response. So I'll set the witness statement to one side for the moment and ask you to have bundle 21, volume 6 before you. And page 3 is where your Direction 5 response begins, or the letter instructing your response begins. Do you see that and do you recall that letter?
I do, yes.
And if we move over one page, we see a series of questions in bold and then your response below them. You recall this document, first of all,
I do, yes.
and are you content to adopt also this as part of your evidence before the inquiry?
Yes, I am content to adopt it.
Now, the one we have before us, section 1 on page 4, is discussing the horn taps. And the question at the top of the page also makes reference to the meeting in June 2014. Do you see that?
I do.
And if you move over a few pages to page 8, at paragraph 1.21, hitherto you've been describing the Northern Ireland incident. At paragraph 1.21, you begin to make reference to what we talked about at the start of your evidence, which was your involvement and awareness of the outbreaks in Northern Ireland and having been invited to attend the meeting in June 2014. You see that?
I do.
And again, you mention here that your invitation was, in the last two lines, to present on the PHE findings and further PHE investigative research.
Yes.
And did you do that at the meeting?
I did, yes. Via
And
a PowerPoint presentation.
PowerPoint presentation, thank you. And indeed, you described that at 122 at the very bottom of the page during the meeting I presented on the findings. What was the gist of your presentation, please?
The presentation was to demonstrate the work which Public Health England had carried out on a wide range of plumbing materials which we'd received from Northern Ireland, as well as the meetings which we'd been involved in with Northern Ireland colleagues. the materials which we'd received, the plumbing components, were shown to be contaminated. Many of them with Pseudomonas aeruginosa. For example, the flow straighteners, in some cases, were over 60% of them contaminated.
I'll just interrupt there, your volume's starting to drop
Again?
a little
Okay.
bit. An inch forward, please.
So the presentation was to look at our involvement within the Northern Ireland outbreak, and much of that from our perspective at Portendown Salisbury was where we investigated many plumbing components in terms of directly recovering bacteria from the plumbing components and looking at these from a microscopy perspective. But the overall work we did demonstrated over 60% of the flow straighteners were contaminated with Pseudomonas aeruginosa, and from the work which we carried out, we then worked with the Department of Health to provide an input into guidance which they later produced as an addendum for advice to reduce the risks from Pseudomonas aeruginosa within what was to be called augmented care units, where patients were at a higher risk to microorganisms.
You mentioned as part of that flow straighteners. Am I right in understanding that flow straighteners are part of the horn taps?
Flow straighteners are part of a number of taps, and at that time they were part of basically all taps. The flow straightener, as I later found out, was also present within the taps which Horn Engineering were producing because they presented at that meeting on their taps.
Okay. Now, we've mentioned the taps twice now, and I think the discussion begins to get quite technical quite quickly about the constitution of the taps. So rather than risk discussing flow straighteners at length without giving you an opportunity to tell us what those are, I wonder if you could take a minute to describe the role of a flow straightener and problems with it.
It's interesting to note that we focus very much on the flow straightener, which is a plastic insert at the end of the outlet of the tap. And this plastic outlet is a multi-layered, highly engineered piece of plastic that is used to provide a uniform flow from the tap to reduce the potential for splashing and potentially in some cases reduce the flow of the water as well. So it provides a uniform flow rather than a dispersed flow that may splash into the water environment.
How does it do that? Is it part of the structure of the design of that particular implement?
Yeah, these were or are highly engineered pieces of plastic designed to provide those particular functions of uniform flow and reduction of splashing.
Can you,
with multiple layers of plastic within them and highly technical.
What does highly engineered mean?
I guess you'd have to ask an engineer you'd have to ask an engineer who designed these units.
Well, it's your expression.
It's my expression.
Dr. Walker.
So when I was involved with the outbreaks in Northern Ireland, we took some of the flow straighteners apart because we had to investigate them and recover the microorganisms. And these were composed of 6, 7, 8 layers of plastic with many multitude of probes and specific parts of plastic that were designed for a particular reason within those different layers. So it's not just a little bit of plastic stuck in the end of the tap with a little hole in it. These are multi-layered. I think there's an image somewhere, Mr. McKeever, of one of these flow straighteners demonstrating the complexity. And that's why I say highly engineered.
Maybe at risk of jumping around, I mean, I think I've got an answer which helps me there. At the risk of just jumping around,
Yeah.
Did I note you as saying earlier that all taps or all modern taps have flow straighteners, or is this something specific, or is there something specific about the flow straightener in the taps produced by the Horn Company So back to my critical question. Would you expect to find flow straighteners in all modern taps?
When the outbreak in Northern Ireland occurred, the taps we investigated all had flow straighteners.
Yes.
And to our knowledge, the majority of the taps supplied to hospitals at that time contained flow straighteners.
Right.
Northern Ireland re-engineered all their taps after their outbreak such that they did not have flow straighteners.
Right.
And it was partly based on our own work and our own investigations that demonstrated that the flow straightener was highly contaminated,
Yes.
and therefore it was one of the components within the area of the last, we call it the last 2 meters, which were contaminated. Therefore, we worked with the industry during the writing of the English guidance, because we as microbiologists and the Department of Health felt that the removal of the flow straightener would reduce the risk of waterborne microorganisms from growing within the outlet where the organisms have got oxygen, have got lots of nutrients.
Now, does that mean that by the time we get to June of 2014, if I was wishing to buy a tap, I would have the option of buying a tap without a flow straightener?
Yes,
Yes, right.
you would have, if you'd been aware of the work which had been going on at the time, if one had an interest in that area, one would have known from the press, from the RQIA, which was the Irish investigation,
missed
the
that.
Irish investigation
Yes.
publication, RQIA, the publication which Public Health England published in journals, and the Department of Health guidance, which the addendum had been basically written very rapidly because of the concerns of the flow straighteners and the potential for the growth in the outlets, demonstrating and indicating that flow straighteners should not be used within taps because of the risk of Pseudomonas aeruginosa growth within that area.
Right. So these are the sources of knowledge. And by 2014, there are such things as taps without flow straighteners.
Correct, yes.
Right. Thank you. Sorry, Mr. McCann.
No, thank you, Rod. You mentioned that there were a picture of a flow straightener somewhere. The description of them got quite technical quite fast, and so I wasn't going to take you to a picture, but I'm going to attempt to do so, and do let me know if I've got this wrong. But if we move forward, sorry, it won't be this document, it'll be back to your principal expert report. If we can look at page 273 of that. Now, this is in the context of a discussion of outlet fittings. And if you see at the top of that page, 520.3, you mention some of the purposes that outlet fittings are for. And that includes 1, flow regulator to reduce flow, 2, flow straighteners to provide smooth flow, and 3, something called aerators. There's a picture of outlet fittings with some contamination in the middle of the page.
Correct.
And then over the page, there is a banner picture across the top, which has either deconstruction of 1 or more outlet fittings. Are these the types of fittings that you have in mind when you're talking about flow straighteners?
That's correct, and that's why, Lord Brodie, I used the expression highly engineered. These are extremely complex. In fact, you can see in the image and the item second from the right, it also has a small rubber washer within it. And again, that small rubber washer would have contributed to the microbial growth. And the item which is second from the left has hundreds of little probes within it. And in an investigation which we carried out, each of those little probes served a purpose as a biofilm generator, biofilm growth. And so you have a huge surface area to volume ratio within these components for microbial growth, increasing the risk of waterborne microorganisms at the end of the taps and the potential for waterborne pathogens such as Pseudomonas aeruginosa growing on those components. And if you go back one page to 273, those components, that flow straightener, which you can see in the middle of the page, was one which was taken from the work in Northern Ireland. And it's important to note that these components had only been in place for 4 months after a refurbishment. That is a highly, highly fouled component from which Pseudomonas aeruginosa was recovered.
The caption there is biofilms and outlet fittings. If we look at the right-hand one and we see gunk, the right-hand picture within that image, the right-hand item within that image, we see brown stains or debris or something. Is that the biofilm? Is that the biofilm that you're referring to?
Yes.
What we don't have on those two images is a scale. How large are these things?
They fit in the end of a tap, so they'll be anything from 15 to 20 millimeters in diameter.
Size of a thumbnail, perhaps?
Yeah.
But nevertheless, when we look at the second image on 274, that's as close as we've got to a folded out image within it. So immediately, just from this image alone, we've got 5 thumbnails or set fingernails for area. But you mentioned also, by reference to the second of the images, that it was covered in probes. By probes, should I understand that to mean raised areas?
Correct, yes, that's a better description.
So each of those will have extra horizontal and vertical surfaces.
Correct.
Within it. And I don't suppose you'll be able to answer this except in the most general terms, but if one were to take the flow straightener and to fold it out, would it follow that we were dealing with a much larger surface area than would be indicated by looking at one's thumbnail? And
very, very much so. And that's where the particular inherent risk from these components come from. And consequently why the guidance was written relatively rapidly by the Department of Health with co-authors to raise the alert that these components can be a risk and to provide advice for hospitals to try to alleviate that risk.
we mentioned, in the context of the flexible hoses, you gave me quite a useful description of what the mechanisms were by which the risk of proliferation perfusion could occur. Can you do the same for these items?
Okay, so as you've washed your hands in a tap, the water will be flowing. You've turned the tap on, your water will be flowing. After you turn the tap off, that water will be retained within the flow straightener. So you have stasis or stagnation. The water which will have flowed through that flow straightener will have been approximately 41, 42 degrees centigrade.
Why is that the case?
Within hospitals, we have a component for the combination of the hot and the cold water called the thermostatic mixer valve. So we talked earlier about the essentials of the controls of the hot water system being calorifier, 60 degrees, leave the calorifier at 60, return at 55. So one of the risks within buildings is scalding if people are exposed to water at 55 degrees centigrade. So to alleviate that and control that, the water is combined within a thermostatic mixer valve. So you combine the hot and the cold water and bring the temperature down to 42 degrees centigrade.
This is before it reaches the tap.
This is, in the case of the QEH, it was at the tap. Okay. So the thermostatic mixer valve is built within the tap component. So you combine the hot and the cold, and the water leaves the tap at 42 degrees centigrade at a comfortable temperature for hand washing.
For the purposes of this question, it's going through the flow straightener at 41, 42 degrees.
So it's going through the flow straightener at that temperature, and you remember the curve we looked at for temperature growth. And so your sweet point is going to be that 35, 40 degrees centigrade. And so for a time period, you're going to have that temperature within the flow straightener, and then it's going to go towards ambient temperature. But the flow straighteners are also going to collect any debris or small sediment, dirt coming through the water. And therefore, that will become a nutrient source for the bacteria. Many of these bacteria also use oxygen and require oxygen for growth. And so at the outlet fitting in the flow straightener, you will have maximum oxygen growth potential, maximum nutrient potential because of the collection of the debris in those components. And you have that high surface area and those multi-complex horizontal vertical components.
Does that mean more nooks and crannies?
Many, many more nooks and crannies, and potentially with where they have the little washers within them. The rubberized material will also provide nutrients and surface area, again, for the growth of the microorganisms.
So to summarise that, there's a coincidence of a large number of risk factors within this small item of equipment.
Correct, and this was recognised through the Northern Ireland investigation and written into guidance and the publications by Public Health England and by the RQIA in Ireland to highlight these concerns and risks and the recommendations that flow straighteners be removed from taps to reduce the risk to vulnerable patients.
Thank you. That's extremely helpful. In a way, we got into that as a digression from the point about the presentation that you gave at the meeting. But I should perhaps have asked one question before that, which was really to take the focus away from one particular item within the taps and to the taps themselves, lest we focus on flow straighteners when flow straighteners aren't the only issue with the taps. I should ask you the question of whether there were any other particular issues with these taps that cause you concern.
Yes, these taps outlets are placed in the last 2 meters, and you have that situation where they're fed by spurs either from the hot or the cold water system. And so the spurs basically, for the hot water system, you have your flow and return circulating system. You have a spur from, for example, the ceiling down to the tap. When that tap's
that's
not
because, just to mention the ceiling, that's because the main pipework runs in the ceiling.
Correct.
And the tap isn't in the ceiling.
Yes, and it could be in the walls or the ceiling, but what you've got to then run from the hot water recirculating system through the tap, and you do that by using a spur. And the cold water system is fed singly through the whole building, and there's no return. So basically that becomes all of a dead leg, but it's also fed by a spur to the individual outlet. So you have a hot spur and a cold spur. And when you're flowing those, when the water is flowed through the tap, then we talked earlier on about replenishing that water, but as soon as the tap is switched off, you have no flow, you have stagnation. And interestingly, the horn taps have 2 levers, and therefore, because you predominantly use the left-hand hot lever to deliver the water at 42 degrees centigrade to wash your hands, then it's been suggested through some of the reports that the right-hand lever may not be used so often. So you could have a small area within the tap where the water through the cold section is not flowing as often as it would be through the hot section. So you could have a higher risk within that. And the horn taps obviously have flow straighteners within them. And we talk about these, you've seen the pictures, the high complex engineering that goes into these units, the multi-layered, the high surface area to volume ratio, the nooks and the crannies that are provided by these flow straighteners.
Am I getting the picture correctly that the source of both hot and cold water is the pipework in the ceiling? You described hot and cold spurs. Now, thinking about the cold spur, you point out that that's likely to be used less because people are principally using the taps to wash their hands. Now, as I say, have I got the picture correctly? You switch off the cold tap using the right-hand lever, and does that leave a column of water filling the spur?
It will depend on how it was plumbed into the cold water system. In some instances, it's not unusual for a separate cold spur to go to the TMV, the thermostatic mixer valve, and then a separate cold spur to go to the cold outlet.
Right. So I'm wrong in thinking that it's necessarily, well, let me ask the question in the other way. Once the cold tap is switched off, would you expect any water to be left stagnant above the tap in the cold water spur?
Regardless of the length of that spur, as soon as the cold is switched off, you will have stagnated water that will sit. Regardless of the volume, you will have stagnated water.
Right.
So once the cold is switched off, and that will be a separate volume from what is flowing through the thermostatic mixer valve. So you will have that area within the cold lever operating, where you have water that is not moving.
Right. And that quantity of water, would it surround, if there is a flow straightener in the, will that water surround the flow straightener? Should I be thinking of a flow straightener which has water surrounding it, or have I got that wrong?
In terms of the water surrounding the flow straightener will retain water once the water flow has ceased.
Right. I think that was my question. Right. So you have a component which, for the reasons you've explained, is likely to be a site for the development of biofilm. Have I got that right?
Yeah, absolutely, yes.
Right. That's probably enough, and will also be wet with the stagnant water.
Yes.
Right.
That's very correct. But to complicate it, when you have your cold spur and your hot spur, so when the tap is not being operated, they become dead legs. Dead legs being stagnant water, being opportunities for microbial growth. So when you then operate the tap, you then flush the water out of the spurs, reducing the microbial content in the water. Biofilm is a different issue. You will still retain biofilm, but the outlet fitting becomes like a focal point of where you will collect sediment, debris, equaling nutrients, assimilable organic carbon for the growth of the bacteria, providing a warm, comfortable environment and temperature for microbial growth opportunities. And you also have, we haven't talked about yet, the exogenous or contamination from outside the tap, which we may touch on later. So there's other complications going on rather than just the tap. But at this point, the flow straightener is enough of a focal point for microbial growth to occur from the water coming through the water system.
Right. Thank you.
I may dwell on this for a minute or two longer, but from a different perspective, which is if we skip back to page 239, which was the pictures of the horn taps themselves.
Yeah.
Now, they look quite different from the mixer tap I've got in my kitchen sink at home. And without looking inside it, as I understand that tap to work, there's a hot tap on one side, there's a cold tap on the other. I flick the levers, and eventually, after too long, I get a flow through that I feel comfortable putting my hands under. That's how it works in my kitchen. My understanding is the horn taps don't work like that at all. The two levers are not doing those functions. Is that correct?
The hot lever will deliver water which has been passed through a thermostatic mixer valve.
It's been pre-mixed.
Pre-mixed, therefore you'll only get 42 degrees centigrade water coming out of it to prevent scalding. So it's to reduce that risk. And your cold lever will deliver cold water only.
So if we have a picture in our mind of everything that you've told us beforehand, we have, say, in the ceiling or in the walls, we have the main cold water and hot water
Correct.
passing through stainless steel pipes. We then have a spur dropping down towards the tap. And you mentioned that if the tap were not used, or when the tap is not used, that acts as a dead leg. And that may or may not be a
Correct.
problem. The spur reaches the tap. Does it follow from what I've said before that there are, in effect, two routes or two channels through the tap?
Yes, because you've got to deliver either water for washing your hands from the hot side or cold water coming through, but it comes out through the same outlet. So it's designed within the tap to deliver the water through the same outlet.
And the flow straightener sits within that outlet, is that
Yes,
correct?
at the very periphery of the tap. So all the rest of the engineering is behind the body in the tap, which you can see.
So the type of water that is getting retained by the flow straightener at any time will depend upon which lever was turned on last.
Yes,
If that lever is the left-hand one, the red one on our picture, then that would be 41, 42 degrees
yes,
water. And that's the risk that you've described to us beforehand. If it's the right-hand one, the blue lever, then that will be cold water that starts out at 20 degrees or below 20 degrees, say.
depends on the length of the spur
Yes.
and the last time the tap was used. So if it's within a nice warm ward, then the water may actually have increased in temperature, and it may also depend on insulation between the hot pipe and the cold pipe. And if there's no insulation, then you'll get heat gain in the cold dead leg from the hot dead leg. And so you may get potentially, as we've noticed within some of the reports, which we may talk about later, cold water examples being 30 degrees centigrade.
Okay, thank you. We're maybe setting that to one side. It's the two channels through the pipe, two channels through the tap point that I'm interested in. What's your understanding as to how these taps are actually used in practice?
From what I've seen written down, then there's a great potential and observation that the hot lever is used more often than the cold lever.
Why is that?
Because staff naturally, one's natural approach to these taps would be to operate the hot lever to deliver hot water at 42 to wash your hands. Why would you operate the cold lever?
What are we know one of the problems posed thereby, because that means that what is in, say, the flow straightener is often within the sweet spot. What are the problems that arise from disuse of the right-hand lever, the cold lever?
So you will then provide a scenario where you have water which is stagnant and sitting in the pipework for a longer period of time.
You say within the pipework, is that within the tap itself or within the spur? Where?
There will be water within the tap body at that point behind the cold lever valve. And then that will then lead to the spur back to your cold water system.
And what's the risk of having cold water lying within that channel within the tap itself?
The problems are similar to the scenarios we talked about earlier, where you have stagnation because that cold lever is not operated. You will have bacteria which will grow in the water phase, but also grow predominantly as a biofilm on the components of the tap within the body of the tap, and then further back in the cold spur because it's not being used.
Does that mean that there should be special instruction for how to use these taps?
One would have considered that the training of these taps and instructions for using the staff who use these taps, clinical staff, staff working within wards, as in how to use these taps so they can understand that they can help alleviate the build-up of microorganisms in the water system and therefore how to operate the tap to reduce those issues of biofilm growth and reduce the potential for waterborne pathogens.
Okay, thank you. I think that's probably all I want to ask you about the internal workings of the taps themselves. But as I said, we got onto that from my initially having asked you about the gist of your presentation that you gave at the meeting in June 2014. I don't think I'll let you finish that answer. I wonder if you can tell us what you said at the presentation.
I was able to present on the findings from the outbreak in Northern Ireland, the Public Health England involvement, and the identification of strains being present on the flow straighteners, the exact strains as was present on the flow straightener and recovered from the patients who had acquired infections within those wards. From our work, it demonstrated that tap components, and as we talk about, one of the areas we haven't talked about is the strainers, which are used as the spurs lead from the hot and cold water system to the expensive tap.
Can you just tell us what a strainer is in brief terms?
A strainer is a little metal crisscross grid that is inserted before the tap is connected to the pipe, and that strainer will retain debris or any material which is larger than the crisscross hairs and stop it from entering the thermostatic mixer valves, because you don't want the valves to fail, because you don't want people to be exposed to water at 55 degrees centigrade. And so the strainer retains debris, but it also then becomes a focal point for microbial growth, and particularly biofilm growth. And as we found again, Pseudomonas aeruginosa. And so we need to take the tap and the tap body as an entity rather than just always focusing on the outlet fitting. So it's reducing the risk overall with taps. And so this is what I was able to present at the meeting, and then back up that scientific evidence which we had, which we published, which RQIA, the Irish investigation, had taken on board, taking that forward with the Department of Health and writing the guidance to prevent other incidents where vulnerable patients have been exposed to Pseudomonas aeruginosa by recommending that flow straighteners be removed from taps.
Thank you. You say that's a recommendation. Was that advice that you gave in your presentation?
Yes. Highlighting the risk from retaining flow straighteners.
What was the specific advice? Was it to remove the straighteners or remove the taps, or what?
The specific advice would be to remove flow straighteners as per the Department of Health guidance, but it's always comes with risk assessing what you're doing and being aware and educating and training of staff so they're aware of what the problems are and they can put their own practices and policies into place to reduce other opportunities and reduce other patients being affected.
Okay, so you concluded your presentation. What happened next?
There was then a presentation from Horn Engineering, who presented some videos and demonstrations and countered the argument that they needed to retain the flow straightener within their tap for its operability.
What was the outcome?
Following the discussions with Horn Engineering tried to demonstrate that they needed to retain the flow straightener, which retained the water phase within the tap. And if you didn't have that water phase, then they were suggesting the bacteria would enter into the body of the tap.
What do you mean, the water phase within the tap?
So Lord Brodie mentioned earlier on about the outlet fitting retaining water after the tap's flow has stopped. And that's what they do. They retain the water phase. And Horn Engineering was suggesting that if they take the flow straightener out, then the water, which otherwise would have been retained in the body of the tap, would flow out. And therefore they were suggesting that that would result in an increased risk of microbial contamination of the outlet fitting in the tap.
Were you convinced by that?
I see no evidence whatsoever that this was related to microbiology.
I may have
And growth.
misunderstood, when I was reading your statement, I may have misunderstood this. And what I'm about to say may be a gross simplification. What it seems to me that you've been highlighting up to this point is the risk of microorganisms having their source within the supply to the tap, including the tap itself and the flow straightener.
Yes.
In other words, the risk is coming down into and through the tap. If I've understood your summary of the Horn engineering counter-argument and the use of smoke testing, if I've understood it, they seem to be talking about a risk coming from from the opposite direction. In other words, they were drawing attention to the fact that the retention of water within the tap provides a sort of a seal to prevent microorganisms exterior to the water system coming into the water system through the tap outlet. Now, that's how I've read your statement. Have I understood your statement?
Yes, that's very nicely put.
Right. So, Horn Engineering, if you are accurately repeating their counter-argument, are not answering your argument at all. Now, have I got that wrong?
No, I think you're correct in that principle.
Right.
But what I was there to demonstrate was the potential for microbial growth occurring in the flow straighteners. And I was there to attend the meeting on behalf of Public Health England to present to NHS GGC on what we had found were the risks inherent in the flow straighteners, the thermostatic mixer valve and the strainer.
Did Horn Engineering really answer that point?
I don't remember that part of the discussion
Right, okay.
took place.
Right.
Having had the two presentations, what was the outcome?
Those present representing NHS GGC and the Scottish hospitals decided that they would proceed with retention of the Horn engineering taps with the flow straighteners.
Now, you mentioned the way you described that decision was it was taken by those present on behalf of NHS GGC. If it was suggested to you that you were also part of that decision-making process, what would you say about that?
I was there as a Public Health England representative. I was not in a position to make a decision on behalf of NHS GGC.
Now, one point that you make in the report, I don't think perhaps we need to go to it, but you may simply recall this, is, or rather the Direction 5 response, is that the decision was based upon the ability to risk manage use of the taps. Can you tell us about that aspect and how content you were with that outcome?
Having been involved in Northern Ireland outbreak where there were deaths of patients due to the dissemination, transmission and exposure of Pseudomonas aeruginosa, and from our work that we demonstrated that flow straighteners were an inherent risk in that example. Having been involved with the Department of Health in England, who wrote an addendum that flow straighteners should be removed, I have to say I was disappointed at the decision which NHS GGC decided that they would proceed with a risk-based approach. Because as a microbiologist who's been involved in biofilms and water systems for very, very many years, the first principle should be to prevent the occurrence of situations where the microorganisms will be provided with an opportunity to grow and proliferate, particularly where patients are vulnerable and high risk.
Would it have been a scenario that could have been risk managed?
Yes.
What discussion was there of risk management at the meeting?
I don't remember that there was much detail at all about how that risk would be managed.
Can you describe for us what sort of risk measures we would be talking about?
Many of the risk measures which we'll be talking about are demonstrated within many of the guideline documents from the Health and Safety Executive, contained within the HTM, contained within the SHTMs, where you would carry out either a Legionella risk assessment or a Pseudomonas risk assessment to assess the water distribution system, to look at what the hazards are in that water system, for example, the potential for microbial growth, and look at the risks in terms of transmission and exposure to patients, such that you can put in place personnel who are well trained and understand water microbiology and water engineering. You can put in communication between your engineering teams and your clinical nursing teams, your infection control teams, and put in strategies to remediate the risks and protect the patients. Without going into any detail, sorry.
Or do I take it from that it's a complicated, the answer to the question is complicated, it's not as simple as flush them once a day?
That's very correct. You would take a bundle approach, a water safety group approach, who would write a water safety plan and back that up with a written scheme, where you have, when I say a bundle, I mean a multitude of approach, where you try to reduce the opportunities throughout the whole system by having a system that is well managed through planned preventative maintenance work, through the estates, through the facilities, right through to staff who are working in the wards, who understand the waterborne risks.
And when you left that meeting, the decision having been taken, did you have an understanding of whether or not that sort of approach was going to be carried out?
That was what was recorded in the minutes, that a risk assessment approach would be used. And that would have included implementing all the control strategies, as well as using microbial monitoring to assess whether your control strategies have actually remediated that risk.
Final question, is that the sort of thing that was discussed at the meeting?
I don't remember the detail of it, but it is contained within the minutes. They decided to retain the taps, and therefore they would have had to implement some form of control strategy.
Okay, thank you. That's the end of that section about those particular taps in that meeting. Lord, that's be a convenient point to break.
Might be a moment for coffee break. Could I ask you to be back for 12?
5 past?
Be taken to the witness room.
Please stand.
Yes, we can. My lord.
Dr. Walker, to return to a favourite theme from this morning, it's been mentioned to me a couple of times during the break that there are people within the room who are still having trouble picking you up. So I'm leaning forward as best I can just now. If you could do the same, it would be much appreciated. I mentioned before we finished off with the break that I'd intended to finish off with the discussion of the meeting in June 2014. In actual fact, I need to return to it for a couple of points. Just now, the first of those relates to the recording of that meeting, and you've mentioned a couple of times of things being mentioned in the minutes.
Yes.
I wasn't going to take to the minutes, but it occurred to me we do have them to hand. Bundle 15 at page 692 ought to be, in fact, here we are, ought to be those. We see it's recorded minutes, a special meeting held in the labs block, as you mentioned, date 5th June 2014, time 11 AM, to discuss and resolve issues with Optitherm taps installed in the hospital. You see that?
Yes.
So chaired by Ian Stewart and present, there's a list of attendees. There are perhaps a dozen names there, and you're about 8 or 9 on the list. You see that?
Correct, yes.
Now, I'm not going to take you through the contents of them, which, as far as I can tell, generally records the presentation and counter presentation. But on the third page, at 694, we have the dispositive part of the meeting, action arising from the presentation, and then decisions made. It's 5.3 that I'm interested in here, because this is the decision to retain the taps. Now, if I read out to you, the South Glasgow Hospital, it was unanimously agreed that as the taps installed within the new build development had complied with guidance current at the time of its specification and briefing, and that the hospital was in the process of being commissioned, it should be regarded as being the retrospective category, not new build. No need to apply additional flow control facilities or remove flow straighteners, and any residual perceived or potential risks would form part of the routine management process. First question, does that broadly correspond to what you were telling us about the actual content of the decision before lunch?
Correct.
The second point is, the first line of it, it was unanimously agreed, is what's stated there. We saw that there were a dozen attendees, of which you were one.
Correct.
The decision is recorded here as being unanimous. I put it to you again that the suggestion is that you were part of that unanimous decision to retain the taps. Is that correct?
I was still retained. I was a Public Health England representative, and therefore I was not part of the decision-making process for which those representing the Scottish hospitals decided.
Was there a vote cast or anything like that at the meeting?
I wouldn't have thought it was a vote as such. I can't remember.
Did you cast?
Right. You make the point that you were there in a Public Health England role
Yes.
by reason of your particular expertise. You say, and that would seem to follow, that you're not a decision maker at that meeting. And then if we look at the particular decision that is recorded, it was unanimously agreed that the taps installed had complied with the guidance current at the time of its specification and briefing. Now, that might have been true. Was it?
Which it was, because
If we're talking,
they
at
were-
least if we're talking about the Scottish
the
guidance.
Scottish guidance, yes.
It should therefore be regarded in the retrospective category, so not new build. Right, I've lost the text, but the decision seems to be as to whether it falls within one category or another, and And it does go on to say there was no need to apply additional flow control facilities or remove flow straighteners. Now, you've told us that what you had done was put forward an argument to the effect that there was a need to remove flow straighteners.
From our Public Health England perspective,
I mean,
and being involved,
right.
having been involved in writing the addendum for the Department of Health with the Department of Health in England, that was the approach which we were taking.
Right. And any residual perceived or potential risks would form part of the routine management process. So seems to be no reference to additional, I mean, according to the minute, no additional measures beyond routine management process. Right. Sorry, Mr. McKeever, maybe
At the risk of
taking up time there.
at the risk of labouring the point, did you have any involvement in the decision to retain the taps?
With my experience, my expertise, and my involvement with the Department of Health England guidance writing that flow straighteners should be removed, then I would not have been party to a decision that I believed would have put people at risk.
Well, you see why I'm labouring the point, which is because of the words unanimously agreed in the first line. Do you agree that it was unanimously agreed to retain the taps?
I believe and understand that it was unanimously agreed by those present representing Scottish hospitals.
If we go back 2 pages and we see the list of attendees, and we see designations after the names. We have Health Protection Scotland twice, NHS Goods of Glasgow and Clyde 3 times, Golden Jubilee, which is a hospital in Clyde Bank, as I understand it, NHS Ayrshire and Arran, then you with Public Health England, then Health Facilities Scotland, and then 2 representatives from Horn Engineering. Which of those individuals should I understand as being part of the unanimous decision?
I would have thought all but myself and those representing the commercial company.
Just to be clear, your position is you were not involved in the unanimous decision.
I would like to state again that representing Public Health England, I would not have been in a position to make a decision for Scottish hospitals.
Thank you. The second point coming out in part from the minutes is that there's reference to what measures would be taken to manage the taps, and there's a reference towards the end of what I read out to a routine management process. You recall that? Who owned that responsibility, that risk?
Can you bring it up on the page?
2 pages on, 694. What I had in mind was the last 3 lines again of 5.3, but in actual fact, the question is broader than that. It's in relation to everything you've said before about having decided to retain the taps, but to risk management, to risk manage that fact. What was your understanding as to whose responsibility that was?
Only those present representing NHS, GGC and Scottish hospitals made that decision, and it would have been for them to communicate that decision. I realise I'm not answering your question specifically because it may not have been those present who had to undertake the actual process of reducing the risk or putting measures in place to remediate the risks, but they would have had to communicate it to colleagues who would then have used their water safety plans and their written schemes in order to ensure that the risk was reduced from the presence of the flow straighteners because of what we've described this morning, the inherent
Dr.
risks.
Walker, if you want me to hear what you're saying, I'm afraid you'll have to up the volume a bit.
Okay.
If you could do that, it would mean that I can hear what you're saying.
Okay.
Sorry, Ms. McKee.
Yes, thank you. You mentioned the word communication there. Another aspect of communication is that I might have asked about was to go back to the recording of the minutes. Did you get a copy of these minutes following the meeting?
I did, yes.
Did you communicate back to NHS Scotland any feedback
I did.
regarding those minutes? What did you communicate back?
There was a couple of minor comments which I added to put more context into the issue of flow straighteners and contamination, and maybe a few other minor additions to the minutes which I sent back.
Did you say anything about the words unanimously decided?
I did not.
Thank you. I'm just going to move on to the next section of my questions. Before I do that, I'm going to return to a matter that I think I covered adequately this morning, but it was to do with adoption of the various statements, reports and so on that you've had before the inquiry. I think you've covered it already, but just for completeness, could I ask you to confirm, perhaps once again, that you adopt your expert report as your evidence to the inquiry?
Yes, I do.
Can I ask you to confirm that you adopt your witness statement as part of your evidence to the inquiry?
Yes, I am happy to adopt the witness statement.
And can I ask you to confirm again that you adopt the Direction 5 response document that you gave in June or July of this year?
Yes, I'm happy to adopt the Direction 5 document. Thank you.
Thank you. At this point, could we turn back to the main report, please? Questions before the break took us up to everything I wanted to say about Section 4. So if we move on to Section 5, which begins at page 245, please. And this section is the description of unsafe water and wastewater drains system. I think I described it to you at the very start of your evidence as, the word was wrong, but as a hypothetical. But perhaps general would be the better word. A general discussion of features, unsafe features that one might see in water systems in general. Is that correct?
Yes.
The first section here is an introduction. 5.1.2 discusses how one goes about assessing whether a system is safe or not. And here you've mentioned 4 bullets, 4 parameters that you would take into account. And they are physical water and wastewater system, manner in which it's operated, evidence of microbial contamination, mitigation and control measures. Do you see that?
I do.
I wonder if you can just expand upon that a little bit. What I have in mind is that you're describing there a system whereby you can't look at one factor and from that draw a conclusion about safety or unsafety. In actual fact, you're taking a more holistic view. Is that correct? And I wonder if you can describe how those 4 things interact.
That's correct, Jess, you are correct. Yes, so it's very much about, we talked earlier on about wholesome water and how that's delivered to the hospital. And by the regulations, wholesome water should be delivered at the tap. And that's determined by how that system has been designed, built, commissioned, handed over, and then how it's managed from that point going forward. And all of this is contained within documents such as the written scheme. And risk assessments are such an important point of this whole process, where you identify the risks inherent within the water system, and where those risks are identified, remediation measures are then implemented to reduce those risks.
So coming back to the four main parameters, does it follow from that that, to take for example, one might have two or three aspects, two or three parameters that were perfect in terms of physical water, manner of operation, but still be brought down by failings in a third or fourth aspect, contamination or mitigation measures?
That's a very interesting expression that you've just used, but it's very apparent that if all of these parameters and systems are not put in place, then you will have a failure or could have the potential for failure. It's a bit like the Swiss cheese model with holes in the cheese. If they're all lined up with the hole going through, then you have a greater potential for risk. And if you put them out of juxtaposition, then you have a control at each stage. But if a number of them are still weak in terms of protection, then you have the potential for exposure, transmission, and risk to vulnerable patients.
But the only way you can assess that is by undertaking a holistic assessment, taking everything into account.
That would be correct. So that would not just be your plumbing system, but it would be your staff as well.
So there are more parameters than simply the four in the bullet
Correct.
point. But it would certainly be too simple, in my understanding, to point at a failing in one parameter and say, this leads to a system that's unsafe, just as it would be too simple to point to perfection in half a dozen parameters and say this equals a system that is safe.
Correct.
Is that correct? So a failure in one parameter can be compensated for by work in another parameter.
Yes.
Is that
Sorry.
that?
Say that again.
Sorry. One might fail, or a failing or something less than desirable in one of the parameters might be compensated for by work carried out in respect of another parameter.
But that failure should still be addressed as part of the risk assessment and part of the mitigation strategy, because at some point it's a weakness in the system and could lead to risk.
Okay, I understand that. Does that amount then to a pragmatic approach towards the question of safety? In two respects, I suppose. Firstly, in that one has not to be over-focused on one particular feature, whether that be good or bad. And secondly, that one has to always be in a position of seeking to improve things.
You used a good word earlier on when you said holistic. And so when you use those other expressions, you do have to look at it overall. You do have to use different bundles and different mechanisms of ensuring that you're reducing those risks. And it brings in those four parameters, as well as the staff, as well as the equipment, as well as the operation, to ensure that you're not leaving risks that would then cause harm to patients.
If we move on a couple of pages, we see here on this page where there are references to an institution and one or two documents that you've already mentioned. 5.1.13 is where you describe water safety group. And 5.1.14, you introduce the idea of a water safety plan. And I think you also mentioned a written scheme, though I'm not sure it's referenced on that particular page. Could you take a minute or two, please, to explain the significance of those three things in terms of maintaining a safe water system?
Yes, so your water safety group is an amalgamation of people taken from within your hospital who all have an interaction with water and responsibility for ensuring that there is safe water for patients. You would select staff, you would appoint them into positions within a water safety group, you would train those staff, and they will represent the different disciplines from within the hospital. That will then enable them to assist in the writing of the water safety plan which is partly where you're implementing risk assessments, and some people some hospitals, institutes may appoint a third party to carry out the actual risk assessment or do it themselves, but they need to be able to understand what the risk assessment is about, such that someone risk assesses the whole system to recognise where there's weaknesses and potential for risk and opportunities for microbial growth, and then to look at what the remedial actions could be to try and control that growth.
The written scheme, is that different again?
So the written scheme takes all of this written material, but goes into much, much more detail, including the members of staff as an appointed person, the responsible person, itemising who those are, and also possibly even looking at who the training of those staff, what training they've undergone. But it also includes the risks, includes the water system, includes schematic diagrams to the detail of someone going into identifying the water systems. When they're looking at risks, if they're identifying risks, then they're identifying what the actual remedial strategy should be and detailing what the remedial strategy is. So it's a lot more depth, detail, and substantial information in the written scheme.
Thank you.
But what you do have to remember is all of these documents, when they're written, need to be live. They need to be updated because personnel change, hospitals change, parts of hospitals change, and the risk assessment itself has to be an iterative process that is ongoing on a regular basis.
The idea of planned preventative maintenance, where does that fit into those documents?
That would be a feature of all of the documents where you're looking at your risk assessments. And part of that risk assessment would be identifying your asset list. Your asset list tells you what equipment you have in your water system and what parts of those equipments need maintenance. And then within your written scheme would be who's going to carry that out, how frequently it's going to be carried out.
One theme that has come out from time to time in the evidence has been the extent to which the hospital had in place those documents at particular times. In your understanding, did Queen Elizabeth have these institutions and documents in place at the correct times?
My interpretation of the evidence which the inquiry has provided to me through the DMA risk assessments was that the documentation was not sufficient at the time of the first Legionella risk assessment and subsequent risk assessments which were carried out in following years.
You mentioned a specific matter in relation to the PPM, which was the asset list or asset register. If there was a period when the hospital did not have an asset register in place, what would be the consequences for carrying out PPM?
In order to carry out servicing of equipment, you need to know where it is. You need to know where all your taps are, your thermostatic mixer valves, your expansion vessels, your water coolers, your ice machines, anything that you have within the hospital.
Yes.
You need to be able to know that you have these to put them onto a list such that they can then be serviced and maintained appropriately according to either the manufacturer's instructions and or through your written scheme, such that you're following the guidance which is being put in place by the HSE or Scottish Health Technical Memorandums.
Thank you. Moving on 4 pages to 251. You're discussing here healthcare associated infections. 552, you start to describe in general terms how these are multifactorial. And you mentioned factors including susceptibility of the host or the patient, presence of bacteria, concentration of contamination, and exposure to the source of the pathogen. And in fact, you expand upon that in the following paragraphs to look at the circumstance of the patient, the pathogen involved, and the environment. does it follow from that that in a hospital the size of Queen Elizabeth, with different patient cohorts, different buildings, different conditions within those buildings, does it follow that the risk of HAIs would vary from place to place and from time to time?
The patients who are most at risk are going to be the most vulnerable patients. And therefore, there may be a certain amount of organisms in the water which will not create a risk to a patient in a general ward. So the risk would not be the same for those patients.
Again, to use the word pragmatism, does that suggest that an approach would be an appropriate approach would be to give more care to certain locations over others?
So that is very much an approach which the guidance takes in being able to identify your high-risk patients, your vulnerable patients, and one of the terms which is used is augmented care. And clinical decisions are taken based on where those patients are placed, depending on the clinical vulnerability and the speciality required. And therefore, yes, it's an issue which has to be addressed within the hospital because they're more susceptible.
If we go over to 253, (5.6.2), you're talking about the risk of microbial proliferation. To maintain a wholesome supply throughout the hospital, water system needs to be risk assessed and managed. Where issues have been identified that would lead to microbial proliferation, then mitigated measures need to be implemented. And you discussed that a little bit before arriving at the bottom of the page. 5.6.7, general mitigation strategies for microbial control in healthcare water systems are considered to be, and there's a list of bullets. Top two we've touched on before: temperature control, then cleanliness in the third, removal of debris and sediment. Fourth is movement, keeping water flowing, and then implementation of a water safety plan and water safety group, as you've described to us a moment ago. Is all of that part and parcel of the kind of pragmatic approach that we discussed a couple of minutes ago? Would that be a fair way to describe how one goes about assessing, managing, keeping on top of a water system?
The short answer is yes, all of them.
Thank you. Over the page, there's the beginnings of a table, quite a long table. It's a list of pathogens, most of which we're not interested in just now, but I wonder, I'll give you 10 seconds with this, 5 seconds with this page to remind yourself of what pathogens you addressed here. Then 255 has 5 others. Over the page, thank you. Page further on, we have 6 or 7 pathogens. And then the end of the table is at 257, closing off with another 5 or 6. Now, I won't read out all 20 or so to you, but some of them have been mentioned as being present at this particular hospital. But I think your list was in general pathogens identified in water systems generally. Was that correct?
So as this was a general section of the report, yes, we're dealing with potentially what is identified as an unsafe system. And these microorganisms have been identified as those which have been identified as causing outbreaks in hospitals related to the water system or particular equipment with which water is associated with. And therefore it was using other people's historical records and the scientific peer-reviewed published data to identify that there's a very, very wide range of either gram-negative microorganisms or acid-fast, such as mycobacteria, which can create infections within hospitals.
Without wishing to dig any deeper into any particular organisms. You mentioned that some of them are gram-negatives. Out of the 20 or so organisms, are some of them more common than others?
Yes,
Are some of them very rare indeed?
some of them are relatively rare in hospitals, but some are more common, and it's going to be dependent on how good the surveillance system is within the hospital. Surveillance being a microbiological surveillance based on when a patient's ill, samples will be taken, and you then have an accumulation of data depending on the type of organisms and number of organisms that have been identified.
The reason I ask the question in that way, approach it from that angle, is that we know that some of the microorganisms are subject to specific guidance. You've spoken about Legionella
Yes.
in particular, I think, has particularly stringent or particularly extensive guidance. Would that be correct?
Legionella has been identified for very many years now as a waterborne organism which grows within the water system, transmitted. What we have to understand is it's Legionella and other bacteria within a water system. So where you identify that Legionella has a capability of growing or the opportunity of growing, then other gram-negative microorganisms will also grow.
Okay. I understand there's also specific guidance about Pseudomonas. Is that correct?
Correct.
And Pseudomonas is a gram-negative
Correct.
bacteria, is that correct? Specific question that I have to you is that where, say, a rarer gram-negative was identified, for which there was no specific guidance, would it be an appropriate approach to apply the Pseudomonas guidance as a means of tackling that issue?
I would go broader than that in terms of what you're looking at. If I understand the question correctly, it's identifying where the risk is within the water system, and the guidance which has been written for Legionella and for Pseudomonas provides you with a framework in order to try to address the opportunities within the system where the bacteria are going to grow and put in remediation strategies to control the growth of those microorganisms.
Insofar as you can give me a yes or no to that, you're confronted with a gram-negative for which there is no specific guidance, would a sensible means of approaching it to be to apply, say, Pseudomonas guidance?
Yes.
Two pages further on is the next section I'm interested in. 5.8, where are pathogens and biofilms located in water systems? Now, we've already spoken a little bit about biofilm, and there's been plenty of discussion about it in other evidence, but it's clearly a concern of yours. Can I ask you to explain in relatively brief terms what's the significance of biofilm within your work?
So we've talked about the water system, the flowing water system, and the strategies for control: keep the hot water hot, cold water cold, keep the water flowing. Bacteria will arrive in your water system within the water phase. Those same bacteria, when given the opportunity, will start to become attached to the surfaces either through gravity, sedimentation, or attraction to a surface for nutrients. That biofilm will then grow on a surface, and as it grows, it will produce products like polysaccharides, which will then encase the bacteria. And as biofilm develops, it will encompass other bacteria, other microorganisms, other sediment and debris to become a niche environment where those bacteria will grow and multiply. And the important point is that as the water flows through the system, when you operate a tap, you will remove the bacteria from the water phase. The biofilm will still be resident on the pipework after you have switched the tap off. You will not remove biofilm from a surface just by flowing water through it, because the water at the edge of the pipework, if you think about the radius, is slower at the outer edges. So you have the biofilm growth on the surface and it is retained within the surface and within the water system.
So there's a step change in nature between the risks posed by free-floating organisms on the one hand, and on the other hand, between organisms that become attached.
Correct, and it's not just a physical attachment, it's the tolerance of those bacteria within a meshwork of the biofilm, that tolerance to biocides, to temperature, and the retention of it and the viability of the bacteria will be retained even with biocides and sometimes when higher temperatures are developed.
And is that a product of the, I think you described it as products that are grown from or ooze out of the substance once it becomes attached?
Once a biofilm is attached, you will then get also removal of biofilm bacteria from the surface, either through natural removal, sloughing, and or pressure fluctuations within the hot and cold water system. So you will then get dispersal of biofilm clumps from within the water system through the rest of the water system. And depending where that happens in the water system, those clumps may still be viable many, many meters away and at outlets, at pieces of equipment. The scenario is if you have decontaminated an outlet using a chemical, if you have biofilms further upstream, then they will recontaminate that outlet.
Is it possible to tell how much biofilm there is within the system?
It's a very good question. You can, there are different strategies you can use to do that. You can take out sections of pipework and plumbing components and analyze them using microbiological methods, either microscopy, counting, visual soiling, or more modern technologies that have been around for a little while now are using devices in order to determine whether biofilm is growing on a surface using an electrical differential.
If you have biofilm or a suspicion of biofilm within the system, what should you do to keep the system safe?
When carrying out any risk assessments, you have to be aware that there will be opportunities within water systems for microbial growth within the water phase. Allowing biofilms to develop will exacerbate the volume, the density of bacteria within the water system. Therefore, like any risk assessment, you have to put mitigation properties in place to try and reduce the volume of biofilm.
We've heard evidence about the introduction of chemical dosing. Would that be an example of a mitigation measure?
Yes, absolutely. In fact, even temperature would also be another mitigation effect. But you have to consider that if you're using temperature, that you will kill the biofilm, but you won't necessarily remove it. So you could be leaving dead biofilm behind, which will leave nutrients available for other bacteria coming through the system.
There are measures that can be taken such that a system with biofilm can nevertheless be made safe. Is that right?
You can reduce, for example, if you are using a chemical, you can reduce the volume and viability of biofilms within a water system. But we had the discussion earlier on around about chlorine, but it would apply to chlorine dioxide as well, which is applied at the introduction of the water to the hospital. But as that chlorine dioxide passes through the hospital water system, the concentration of it will reduce because it's being exposed to organics and other properties. It will degrade such that you do not have the same concentration at the outlet as you had when you put it in, and therefore it will not be as effective at biocide further away from the point at which the chemical was introduced.
Okay, that's
So
a helpful.
basically, it's not a panacea.
No,
Just because you've introduced a chemical does not mean your entire system is safe. It may be safer, but unless you're carrying out your risk assessments, your plan preventive maintenance, and everything in your water safety planning, your scheme, then there could be the weaknesses which you discussed earlier on occurring.
Okay, that's a helpful answer. What I had in mind was not so specific as dealing with dosing particularly, but it was the general principle that, I suppose, relating back to the 4 parameters and to the pragmatic approach that we suggested earlier on, presence of biofilm would be an example of one of those parameters having gone wrong. Would that be fair to say?
Yes.
But that one could nevertheless render the system still safe by making sure that, for example, the 4th parameter, the mitigating measures, were in place, and the 3rd parameter, the system was properly maintained or operated, plus other parameters, and it would be on a assessment of all of those together that one would have to come to the view of whether or not we were dealing with a safe system or not.
I think I would prefer the word safer rather than safe. You're reducing the risk. You cannot remove the risk completely. And we have to be aware of that. And that's partly where the guidance always comes from, making the system safer.
I understand the point. I'll maybe just move on to 4 pages to 263, 5.11. What are the foreseeable risks that result in unsafe water? Now, you've listed in this section a number as we go through it onto the next page. Back 1 page. And perhaps probably shouldn't go through, try to pick through any points from this, but in general, you're listing aspects of risk: physical infrastructure, management of the system, and then over the page, the presence of microbial contamination. Again, the question may be the same one as I've just asked you, but are those the parameters that you're looking at when deciding whether or not you're dealing with a safe or an unsafe or safer system?
There would be a number of components which you would include, yes.
Specific point that I'm interested in here is the phrasing at the very bottom of the page, 5.11.6. Thirdly, and perhaps most fundamentally, microbial contamination of the water system. The word contamination here is something I'm interested in. Do you recall that you were asked about that in your Direction 5 response?
Yes.
If we can maybe bring that up, which was Bundle 21, Volume 6, and it was the first document there. It started at page 3, but the question dealing with contamination should be at page 36 of that document. Now, I'm interested in exploring a bit further what you mean by contamination, and I'm going to take you to that question by looking at 1 or 2 points from this passage. At 7.2 here, you are acknowledging a point we've touched on 2 or 3 times before. As discussed in my report, water delivered to hospitals must be wholesome. The water will still contain bacteria, and there are prescribed tests that must be undertaken to prove that the water is wholesome. Correct?
Correct.
7.6 at the foot of the page, you give an opinion that the hospital water system from the tanks, calorifiers, expansion vessels, associated hot and cold pipework and flow straighteners were contaminated with a high level of sediment and detritus as a result of the bypass hose. So that's contamination with foreign material, sand, organic matter,
Yes.
things like that.
Because it bypassed the ultrafiltration unit.
Yes.
Therefore, the ultrafiltration unit is there to take out sediment, debris, and infect bacteria as well. So if you bypass the ultrafiltration, then you're basically contaminating with material that otherwise should have been removed.
Thank you.
From one perspective.
So that's contamination with that type of material, debris. 7.7 over the page, you talk about this again, but slightly different. After the bypass has been removed, the water system was already contaminated by sediment and waterborne bacteria. Now, am I correct in reading this that you're talking about the type of contamination that we spoke about a moment ago, sediment debris, but also here you're introducing the idea of contamination by bacteria.
Yes.
And at 7.8, you say this extensive contamination was presented in the Intertech microbiology reports, which were 2 or 3 reports that you footnoted. And you return to the idea of microbial contamination at 7.10. The evidence presented to you by inquiry demonstrated there was inadequate management, lack of training, poor communication, which resulted in microbial contamination of the water system with a range of gram-negative bacteria. My question is that you're describing what seem to me to be 2 different types or 2 different sources of contamination. One is debris or sediment, the other is microbes. Are those completely distinct types? Should I understand them as in the same way, or are they different things?
They are components which would have been delivered within the water phase because it bypassed the ultrafiltration units. The sediment, the debris, and organic material will provide nutrients for the growth of the microorganisms. The water which would have been delivered would have been wholesome as defined by the requirements, so it would not have been sterile.
Okay, that last point is perhaps encapsulates why I'm interested in the distinction, because debris, I think I understand, because debris is stuff that isn't water and shouldn't be within the water. So if it's contaminated by debris, that would seem to be relatively straightforward. What's less clear to me is contamination by bacteria. As you say, wholesome water will have microorganisms within it. My question then is, where is there a line? Where does one cross from wholesome water with the presence of bacteria into contaminated water because it's contaminated with bacteria?
Where the line crosses is where you provide opportunities for growth of those organisms which have been delivered as wholesome water. As that water is within the building, where you provide nutrient sources which otherwise would not have been there, and you provide temperatures for the optimal growth of those microorganisms, you will raise the level of number and concentration of bacteria to a level that would be considered unsafe.
Are you equating contamination with unsafeness?
I am trying to draw the distinction that wholesome water will contain a certain amount of bacteria within it, where you're then providing nutrients and opportunities for growth. You will have more bacteria, and that will then lead to further numbers, proliferation, and growth of those microorganisms.
I think I'm on top of that process, but it's the specific word contamination, and perhaps because I'm a lawyer, but it's that specific word that is of interest to me, particularly because this section is about contamination, in part about contamination with microorganisms, with bacteria. Okay. What should one understand by contaminated with microorganisms or bacteria?
We have to put this in context of the ultrafiltration unit. The ultrafiltration unit would have removed the organisms from the water. But because it was bypassed, then you're actually contaminating the system, because otherwise it would not have had those microorganisms within the water phase. It would have been taken and removed by the ultrafiltration unit, which is why I've used the word contamination at that point.
We haven't touched upon the ultrafiltration unit before, but are you telling me that the ultrafiltration unit ought to have led to the water coming into the hospital being sterile?
Fundamentally, the output from the ultrafiltration unit would have been a bacterial-free water. What you have to take into consideration was when the hospital was built, that the practices used at the time, through the lack of end caps, the system being filled with water and the water being retained or flushed and then retained, at that point in time, there will be microorganisms within that water because it didn't go through the ultrafiltration unit, is my understanding.
You started out by making it quite clear that wholesome water will nevertheless still contain microorganisms.
Yes.
It seems to follow from what you told me that where there's wholesome water circulating, if there are dead legs, debris, wrong temperatures, then the wholesome water can turn into water where the organisms already present begin to proliferate and there's a problem.
Yes.
Is there a set point where the wholesome water becomes contaminated water?
Where it's not managed, where the risk assessments are not implemented, where the planned preventative maintenance is not undertaken, where the staff are not trained, where there's a lack of communication between staff, then the risks which have been identified in the system are not addressed.
So where you've used the word contaminated and its derivatives here, should I perhaps understand that as being less an adjective to describe the water and more a description of the management of the system?
Yes.
Contamination or contaminated water isn't a term of art, is it? It's not a. It doesn't have a specific definition. Does it?
Not that I'm aware of, no.
Just before I lose this point, there was an exchange, Mr. McKeever, in relation to ultrafiltration. Now, this is not a topic I have picked up on, and I'm not really sure that I understood what was the point arising. First of all, does your report talk about ultrafiltration at any stage?
Yes,
It does.
it does.
Right. Can you point me?
Oh, Mr. McKeever?
It may be.
I don't have it in front of me,
Come
sorry.
on to it probably shortly after lunch because there was
Well,
discussion about the bypass that Dr. Walker also mentioned.
Right. Okay. Because I'm taking from Dr. Walker's answer that ultrafiltration achieves sterility. Now, if this is relevant, I need to follow that. And at risk of maybe preempting matter that you're going to deal with in greater detail, is it practical to install and maintain a water system which entirely excludes the possibility of an environment which promotes microbial growth following the input into the system from the public supply?
Yes,
Right. That's
for very specific and particular reasons.
sorry.
For very specific and particular reasons.
Right. You may or may want to develop on that
I may
in
do
the
so.
afternoon.
Yes.
That is sufficient for my purposes at the moment.
I notice we've ticked past 1 o'clock. I wonder if I might take the opportunity to reflect upon that at lunchtime.
Could I ask you to be back for 2 o'clock, Dr. Walker?
Yes, thank you.
Please stand.